Hello everyone, my name is Vidya and in today's video I'm going to teach you how to solve numericals on modular exponentiation very easily using Euler's theorem. If you check out my previous video given in the link above, I'd explained what is Euler's theorem and the significance of Euler's theorem. So without wasting much time, let us move ahead with solving the numericals. When you get such kind of questions of the kind a raised to x mod p, first step would be you will check if GCD between a and p is equal to 1. If GCD between a and p is 1, then immediately it should click us that we can use Euler's theorem. So what does Euler theorem state? That a raised to the Euler totient of p mod p can be replaced by 1. However, in order to compute phi p, you should be able to check if the number is prime, composite or raised to the power of prime. So in these three questions, you can see that in question number 1, I have considered phi, which is a prime number. In question number 2, I have considered modulus of 15, where 15 is not a prime number, rather it is a product of two prime numbers 3 and 5. So 15 is a composite number. And in question 3, I have taken modulus of 16, where 16 is again not a prime number. 16 can be represented as 2 raised to power of 4, where 2 is a prime number and hence 16 is a power of prime number. Since the value given for modulus is different for the three cases, the formula that you will be applying for Euler's totient will be different. So what are the formulas? If p is prime, we use the formula phi of p as p minus 1. If p is composite, that is p is x into y, you will use the formula x minus 1 into y minus 1. And if p is power of prime, that is p is x raised to e, in that case you will use Euler totient with formula x raised to e minus x raised to e minus 1. So you will compute the Euler totient using these three formulas. Now let us solve these three questions individually. Now here we have to solve this question, that is 2 raised to 4 mod 5. Let us first write it in the form a raised to x mod p. Therefore a is 2 and p is 5. So whenever you have been given modular exponentiation question and you want to solve it faster, you always go for Euler's theorem. So Euler's theorem states that in step 1 you have to check if a and p are relatively prime. So for that you have to check the greatest common divisor between 2 and 5. Is it 1? So how will you do it quickly? You take a calculator and divide 2 by 5. And if you get it as a fractional number, that means the only common divisor between 2 and 5 is 1. Therefore, the greatest common divisor between 2 and 5 is 1. Since GCD of 2 and 5 is 1, we can then go to step 2. In step 2, you have to identify if p is prime or composite or power of prime number. In this given question, p is 5 and 5 is a prime number. So since it is a prime number, we can now compute the Euler totient of the prime number p by using formula p minus 1. So Euler totient of phi is given as phi minus 1, that is equal to 4. And in step 3, we can now directly use Euler's theorem, which states that a raised to phi of p mod p is equal to 1. Therefore, what is a? A is 2. What is phi of p? That is phi of Euler totient of phi. It is 4. Mod, what is p? P is 5. So 2 raised to 4 mod phi, you need not calculate it using traditional squaring method or any other method. You can directly use Euler's theorem and replace it with 1. Therefore, for this question, the answer of 2 raised to 4 mod phi is equal to 1, which also means that if you divide 2 raised to 4 by 5, the remainder of the division is 1. So modular arithmetic basically provides us the remainder. So the remainder of 2 raised to 4 divided by 5 is 1. Let us now solve the second question. Now As I mentioned, whenever you have been given the question of the kind a raised to x mod p, it should immediately click us that we can use Euler's theorem, provided the GCD of a and p is 1. Now the given question is of the kind a raised to x mod p, where a is given as 2, p is given as 15. So since it is a modular exponentiation question, we can apply Euler's theorem. However, for Euler's theorem, step 1 states that the GCD, that is the greatest common divisor between 2 and 15, should be 1. Now you take a calculator and check 2 divided by 15. If you get a fractional number, that means the common divisor between 2 and 15 is only 1 and there is no other common divisor, that is the greatest common divisor between 2 and 15 is 1. And since this condition is satisfied, we now move on to step 2. In step 2, since we have to apply Euler's theorem, we should be able to compute Euler's totient. And to compute Euler's totient, you should be able to identify if p is a prime number, composite number, or raised to the power of prime number. So in the given question, p is equal to 15 and 15 can be represented as 3 into 5. So p is a composite number. And since that is p is written as x into y. So how do you compute the Euler totient for a composite number? It is computed as x minus 1 into y minus 1. Therefore, the Euler totient of 15 will be x is 3. So 3 minus 1, y is 5. So 5 minus 1, which comes out to be 2 into 4, that is 8. Therefore, we got Euler totient of 15 as 8. After computing the Euler totient, we move on to step 3. In step 3, we use Euler's theorem. Now, what does Euler's theorem state? It states that a raised to power of phi of p mod p can be replaced with 1. Now, what is a in our question? 2. What is phi of p? Phi of 15? Phi of 15 is 8. Mod. What is p? 15. So 2 raised to 8 mod 15 is 1. So it means that you need not compute 2 raised to 8 mod 15 using the traditional squaring method. Rather, you can directly apply Euler's theorem and replace it with 1. So in this question, we got 2 raised to 8 mod 15. The answer is 1. Or rather, this can also be read in the other way, that is, the remainder of 2 raised to 8 divided by 15 is 1. Let us now see the third question. Again, the given question to be solved is of the kind a raised to x mod p. So we note down what is the value of a, that is 3. We note down value of p, that is 16. Now, since we have been given a modular exponentiation question, we know that we can apply Euler's theorem. However, to apply Euler's theorem in step 1, you have to check whether 3 and 16 are divisible or not. So, you take a calculator, divide 3 by 3 and 16, you will get a fractional number. That means the only common divisor between 3 and 16 is equal to 1. Therefore, the greatest common divisor between 3 and 16 is 1. And since the GCD of 3 and 16 is 1, that means 3 and 16 are relatively prime numbers. We can now move to step 2. Now, since we are solving this numerical using Euler's theorem, in step 2, we should be computing Euler's totient. In order to compute Euler's totient, you should be able to identify whether p, that is 16, in this case is a prime number, is it a composite number, or is it a power of prime number? Now, 16 is not a prime number. Rather, 16 can be represented as 2 raised to power of 4, where 2 is a prime number. So 16 is a power of prime number 2. Therefore, since p is of the kind x raised to e, the Euler totient of p can be computed as x raised to power of e minus x raised to power of e minus 1. So the Euler totient of 16 can be computed as x raised to e. What is x raised to e? That is 2 raised to power of 4 minus 2 raised to power of 4, and here we have to do 4 minus 1. So what is 2 raised to power of 4? 16. And what is 2 raised to power of 3, it is 8. So 16 minus 8 is 8. Therefore, the Euler quotient of 16 that we got is 8. Then we move to step 3 where we apply Euler's theorem. Euler's theorem states that a raised to phi of p mod p can be replaced as 1. So what is a for us? It is 3. What is phi of p? That is 8. Mod p, what is p? 16. So 3 raised to 8 mod 16, rather than computing it using squaring method, which is lengthier method, because the GCD between 3 and 16 is 1, you can easily apply Euler's theorem and write this entire thing 3 raised to 8 mod 16 as 1. So my answer to 3 raised to 8 mod 16 is equal to 1. That also means that the remainder of 3 raised to 8 divided by 16 is equal to 1. So we have come to the end of today's video. I hope you all understood the concept of Euler's theorem. Kindly let me know in the comment section. So thank you guys. Thank you for watching my video. See you in my next video. Stay happy, stay healthy, stay blessed.